Thanks everyone for inviting us to speak today. So I'll give a split presentation. So I'll start, then we'll bring Matt in, then I'll then finish off as well. I'm from the climate change and zero waste team in Fife Council. And for anyone here who doesn't know where Fife is, in Scotland, it is just north of Edinburgh. We are the third largest local authority in Scotland, with about 375,000 people and 200,000 buildings. And a third of people live in 3 settlements, Dunfermline, Kirkcaldy and Glenrothes. We're also home to the globally renowned town of St Andrews, which sits in the northeast corner of Fife. So that's famous obviously for the Golf University. And whilst not in scope for mine water heat schemes, there are other types of geothermal potentially located nearby in that location. In terms of district heating, we already have 3 district heat networks in Fife. We have the Dunfermline Community Energy Scheme, which is heated by landfill gas, CHP, anaerobic digestion, and a small biomass plant. There's also another council-run heat network in Glenrothes, in the centre of Fife, which is biomass, and the university in St Andrews also has another heat network, again by biomass. Fife is well known for its coal mining history, and we are actively exploring how we can utilise the mine workings to provide heat to our existing networks or for new district heat networks moving forwards. Coal mining became a major industry in Fife from the 1800s, especially in West and Mid Fife, with over 50 deep workings and open cast collieries in operation. The population grew rapidly during this time, often in Mid Fife, with actually a creation of new towns, with the biggest being Glenrothes. In total, there are about 3,600 recorded mine entries, and about 204 kilometres of land is development high risk due to these mine workings. The last pit closed in 2002, which is Long Gannet, and many former mining areas now experience high levels of fuel poverty and deprivation, which, as you can imagine, reducing poverty and tackling deprivation is a key priority for the council, as well as meeting net zero. And therefore, we kind of see the opportunity to utilise mine water heat as an opportunity to tackle both of these. This brings us on quite nicely to local heat and energy efficiency strategy. So our local heat and energy efficiency strategy, or ALHES, is a strategy which explores how to decarbonise heat and improve the energy efficiency of all buildings in the council area. And all Scottish councils were required to produce one of these every 5 years. We framed our ALHES around the 8 priorities which are on the screen just now, with fuel poverty captured in priority 2 and heat networks falling in priority 8. We see heat networks as a key mechanism for decarbonising heat at scale, as well as being used to help meet our other priorities and those of our stakeholders, so such as tackling fuel poverty, as I mentioned, but also to transition the wider energy system and build community wealth. The strategy identified potential areas for heat networks, as well as heat sources across the whole council area. And heat sources include things like sewer and the rivers, but also mine water heat from borehole and mine water treatment schemes. So to help explore this opportunity, we have worked with the UK's Mining Remediation Authority. And I'll now hand over to Matt, who will give an overview of this work, and then I'll come back in to discuss our next steps.
Thanks, Hamish. Yes, we were commissioned by Fife to produce an opportunity map in, I think it was 2021 now. It was supposed to be just an opportunity map for borehole-based schemes. But after some discussions with the council, it evolved into something a bit more than that. So this bespoke opportunity map was a combination, really, of a number of data sets. From the Mining Remediation Authority, we used our underground workings polygons, we used the depth of the workings, and we also use the coordinates of the mine water treatment schemes. But then after some discussions with the council, we also decided to add areas of vacant and derelict land and settlement boundaries. And I'll explain the reasoning for that in one of the later slides. If you could just move the slide on for me, please, Hamish. Thank you. So if you were either a planner or an energy officer looking to explore the potential of mine water in your borough, your first port of call would probably be the interactive viewer. And in this instance, it probably wouldn't help you. You would be aware that your area has got a lot of mine workings. Your red line boundary sits over the mine workings, but then what? So we know in this area in Fife, there are up to 34 individual seams. And on this polygon, this green polygon, you can't tell whether there's one seam beneath your site or whether there's 34. So it's it's of little real use really to your officer, and they don't have lots of time to spend like digging into the mining history. So what we need to create is a tool for the non-specialist to quickly be able to identify opportunities that have got real potential, because you don't want to be wasting your funding on something that's not suitable. And we know funding's hard to apply for, and the funding rounds are competitive. So if you do go for funding, it needs to be something that's got real potential to be turned into a scheme. Could I have the next scheme, please? Next slide, please, Hamish. So what we came up with was it was initially a red, amber, green map. And if you're on a red area, you would know that there's no mine workings beneath the site, and there's no potential for a heat network and no future potential for a heat network based on the mine workings. If you're on an amber, amber is still good. It means you've got the required underground elements. So you've got a number of overlapping seams beneath your site, but you don't have land above the mine workings with funding attached to them. So as I mentioned in the previous slide, the settlement boundaries and the areas of vacant and derelict land, after discussions with Ian and his team at the council, we knew that these two parcels of land have funding attached to them that could potentially be used for feasibility studies for mine water projects. So this is what the green polygon on the opportunity map will show you. It will show you you've got what we think are the prerequisites for the underground element. You've got multiple seams stacked upon one another, and then you've also got land at the surface with funding attached to it to potentially pay for your feasibility study. But just a note of caution: just if you are on a green area, it's not a guaranteed success for the site. You still need to come and have a chat with a mining remediation authority, and you do need to have your feasibility work, so it doesn't give you an initial answer whether it's feasible or not. Could I have the next one, please, Hamish? So this is what the opportunity map came out like. So as you can see, we didn't show the red areas. We thought it would be a bit distracting to have huge swathes of red on the map. So we just concentrated on the green and the amber. So you can see there, the amber are the areas where you've got multiple mine workings stacked upon one another. And then the green areas are the ones where you've got the mine workings beneath your site, but you've also got those parts of land at the surface that have funding attached to them. And then something else we've shown is the positions of the mine water treatment schemes. Now, we had to do these a little bit differently because we know the treatment schemes are there. It's not going anywhere. The challenge then becomes a little bit different. It's how far could you potentially export the heat from the mine water treatment scheme to get it to either a green or an amber one. So you've got areas where amber areas, green, and then the circles with showing the positions of the mine water treatment schemes. And then I'll hand you back to Hamish.
Thanks, Matt. So we're now, in terms of next steps, we are in the delivery stage of our local heat and energy efficiency strategy, where we have specific actions to investigate heat sources and expand and create heat networks. And within the council, there's a great interest to further progress our understanding of mine water. A slight segue, but at the moment we are prioritising Dunfermline and Fife, where there is an existing heat network, but it needs new heat sources, with the main heat source, which is landfill gas, it's likely to run out as the landfill closes. Or another challenge around this area is most heat sources are low temperature, including the mine water, so we'll need boosted by a heat pump, and the grid in the area is extremely constrained. So we must also consider, when we expand the heat network, how it'll interact with electricity grid, and are there other constraints or opportunities in terms of generation we can consider. Pitferron mine water treatment scheme is one of 4 newly identified major heat sources in the area, and has excellent potential, we think. We also conveniently own an abandoned rail line which runs from near the treatment scheme close and runs near to our existing energy centre for the heat network. We have now commissioned the Mining Mediation Authority to undertake a de-risking exercise on Pitferron, which is looking at the things in the green box on screen, such as assessing the drainage infrastructure, hydrogeology and historic data, identifying safe locations for surveys, and assessing areas of vacant and derelict land which could be used for further studies. We then, depending on the outcomes of this, would hope to take this to a detailed techno-economic feasibility study. And if successful, we can connect Pitferron up to existing heat network. We could have the first heat network in the UK using heat from a mine water treatment scheme. Just quickly show where Dunfermline is on screen here. That is the other heat source identified. There's Pitferron there in the west. We have land from the north, the River Forth, and some sewers in the south as well. And for the wider opportunities in Cross Fife, we have 153 identified potential heat network zones using an innovative zoning approach we developed with input from Vattenfall. We still need to formally designate these zones, and not all will be formally designated, but it shows we have great opportunities for heat networks across Fife. And finally, obviously, Pitferron is our immediate focus for Dunfermline. But we also want to eventually look at other mine water treatment schemes or borehole opportunities, some of which of the key ones are on screen just now. So there's Francis mine water treatment scheme in Kirkcaldy. There's ongoing development in Comrie looking at mine water heat. And there's also things such as maybe could there be heat storage opportunities in Glenrothes as well. Overlaying the map Matt showed with our heat network zones kind of again shows you where we have these potential mine water heat opportunities. Fife are keen to be the leading council in Scotland on mine water heat and hope we can come back at a future event and showcase the success we've had with Pitferron and or other opportunities as well. So thank you very much for your time.